Picture a tiny moon, barely bigger than a city, hiding a secret ocean beneath its icy crust. Could it hold life? This isn't a sci-fi plot, it's Enceladus, Saturn's moon, stealing the spotlight in our solar system. Recent discoveries of organic compounds in its plumes have scientists buzzing. These molecules, the building blocks of life, suggest Enceladus's ocean could be a cradle for alien biology. Let's dive into this icy world's secrets and see why it's rewriting the hunt for life. Enceladus, one of Saturn's 146 moons, spans just 313 miles, smaller than Hawaii's Big Island. Discovered in 1789 by William Herschel, it seemed unremarkable through early telescopes. Just a pale speck near Saturn's rings. But NASA's Cassini spacecraft flipped the script. Launched in 1997, Cassini reached Saturn in 2004, and in 2005, spotted geysers blasting water vapor and ice from Enceladus's south pole. These plumes weren't random, they hinted at a liquid ocean beneath the ice, warmed by Saturn's gravitational tug flexing the moon like a cosmic stress ball. Why water sparks excitement? Why does this ocean matter? Water is life's playground. On Earth, oceans nurture everything from microbes to whales. Could Enceladus's ocean do the same? Early Cassini data confirmed a salty sea with silica from hydrothermal vents and hydrogen gas, a microbe's energy drink. But life needs organic molecules, carbon-rich compounds that form proteins, DNA, and more. Until recently, organics were sparse and vague. A 2025 study changed that, uncovering a rich mix of compounds that scream habitable. Cassini's plume hunting legacy. How do we know what's in that ocean? Cassini's flybys through Enceladus's plumes were like sipping from a cosmic straw. The Ion and Neutral Mass Spectrometer, INMS, sampled the plumes, which carry ocean material into space. In 2015, during the E2 flyby, INMS found molecular hydrogen, proof of hot water reacting with a rocky seafloor, similar to Earth's black smoker vents that host life. By 2017, phosphorus, a key DNA ingredient, appeared. Enceladus had water, energy, and elements. But the organic puzzle piece was missing until now. A breakthrough in old data. What if a single flyby held the key to alien life? In April 2017, during Cassini's E5 flyby, the Cosmic Dust Analyzer, CDA, zipped through the plume at 17.7 kilometers per second. Ice grains smashed into the detector, vaporizing into particles for analysis. In 2025, scientists at Freie Universität Berlin, led by Nozair Khawaja, reanalyzed this data using advanced mass spectrometry. Comparing smash patterns to lab databases, they found type 2O grains packed with fresh organics, ejected from the ocean just minutes before. A chemical party in the plumes. The findings? A molecular fiesta. The team identified aromatics like benzene, the backbone of DNA bases and proteins. Aliphatic oxygen compounds such as acetaldehyde, think green apple scent, could form sugars. Esters like allopropionate with its fruity whiff. And alkenes hint at lipid-like molecules for cell membranes. Ethers, including diethyl ether, and nitrogen-rich compounds like pyridine derivatives and nitriles, potential amino acid precursors, rounded out the mix. These molecules, mostly under 125 atomic mass units, suggest fragments of larger, complex chains. How rich are these organics? Quantifying concentrations is tricky at such speeds, but these organics are enriched compared to Saturn's E-ring, which holds older plume debris. This suggests active chemistry in the ocean, likely in hydrothermal vents where hot, mineral-rich water meets cold sea. On Earth, similar vents sparked life billions of years ago. Fabian Klenner, a University of Washington postdoc, noted, "We found a rich organic inventory in Enceladus's plume. This strengthens its potential for habitability, the habitability trifecta." Enceladus feels like Earth's cosmic cousin because it has all the key ingredients for life. Beneath its icy crust lies a global ocean, 6 to 19 miles deep, filled with salty water rich in sodium chloride and carbonates, just like Earth's seas. This mix gives it an ideal balance for life. Then comes the energy. Saturn's gravity squeezes and stretches Enceladus, creating tidal heat that warms the ocean. This heat powers chemosynthesis, life forms that feed on chemicals instead of sunlight. Finally, there's hydrogen gas from rock and water reactions, detected at up to 1% in the moon's plumes. For microbes, that's like an endless buffet. Organics. The third piece, organics, is now a star. Earlier finds showed simple chains and salts, but the 2025 study adds complexity. Aromatics for protein rings, nitriles for sugar pathways, pyridines like vitamins. These sketch a prebiotic soup. Kawaja explained, hydrothermal fields likely exist at the ocean floor, where hot water rises. Life on Earth may have started in such vents. Enceladus isn't just wet, it's a potential birthplace for biology. Cautious optimism in the search for life. Life on an ice moon sounds thrilling, but science demands caution. These organics could form without biology. Lab tests mimic vents and make similar compounds. The ocean's isolation, locked under ice with no sunlight, means any life would be tough, like Earth's extremophiles. Plumes sample the ocean unevenly. Some grains might come from surface fizz, not deep vents. Still, the E5 data leans oceanic, and the case for habitability grows stronger. Enceladus versus Europa. Far from Earth, two icy moons. Enceladus and Europa hide oceans beneath their frozen shells. But Enceladus may hold the upper hand. While Europa keeps its secrets locked under miles of ice, Enceladus sends geysers of water vapor shooting into space, offering clues without drilling. During its 2017 finale, NASA's Cassini spacecraft flew through these plumes, collecting samples that hinted at life-friendly chemistry. As scientist Frank Postberg's team continues studying the data, researcher Klenner said, "It's phenomenal to keep learning from Cassini. Much of the CDA data is still unanalyzed. Enceladus, it seems, keeps whispering secrets from Saturn's shadow, and scientists are still listening. Future missions to taste the ocean. What if we could sip that ocean directly?" NASA's proposed Enceladus Life Finder, LF, would orbit and sample plumes for biosignatures, amino acids, lipids, or isotopic hints of metabolism. ESA's Enceladus Explorer, eyed for the 2030s, might drill through ice. China's Tianwen-4 could visit Saturn, targeting Enceladus. By 2040, we might confirm microbes. These missions hunt disequilibrium chemistry, gases out of balance, a sign of life. Enceladus as a life factory. Think bigger. Enceladus could seed life across the solar system. Its plumes feed Saturn's rings with organics, perhaps sparking chemistry on Titan, the methane lake moon. The Guardian calls Enceladus a fertile hunting ground, with diverse carbon compounds showing life's ingredients are common. If Enceladus hosts life, so might Ganymede or Ceres. With over 5,000 exoplanets likely holding oceans, finding life nearby could redefine biology. Challenges in dreams, radiation fries, Enceladus's surface, and ice hides clues. Missions like Cassini cost $3.26 billion, and budgets are tight. But the payoff? Proof we're not alone. Klenner sums it up. Enceladus has all the ingredients for life as we know it. From benzene to ethers, this moon whispers possibility. In conclusion, next time you glimpse Saturn's rings, partly made of Enceladus's icy breath, pause. Beneath that frost in ocean dreams? Is it dreaming of us, or something alive in its depths? The hunt for life just got hotter, and Enceladus leads the way. The plumes keep calling and we're listening. If you love this, subscribe and join the conversation in the comments. More content are on the way. Thank you.